Thank you, CackalackyCon, for not sticking me in the crap slot. And I realize I am the only thing standing between you all and lunch, so I will try to shove all this into an hour. Bear with me. I'm Dan Helton, as you introduced, from NCC Group. I'm a senior consultant. I do a lot of web app and NetPen and red teaming. I'm something of a geek for computer history and esoteric operating systems, which got me into mainframes. I'm probably the only guy in here who has an open VMS hobbyist license. Anybody in the house work for IBM? Not a soul. A1 used to be a mainframer or work on mainframes before. Oh, a few, all right. So I'll share a little bit of your guys' secrets with us uninitiated here. Also, there's my Twitter handle and my blog. I'll have this presentation. I'll have a Google Drive link up to the presentation, and I'm going to write some blog posts in the near future on all this stuff. And yeah, you can blame me for the broken RMI challenge in the CTF. So what is a mainframe? It almost always means IBM Z hardware. And there's a few other players. There's like Unisys and Fujitsu, but the main mainframe maker is IBM. It's almost always Z hardware, and it's almost always ZOS, which is their flagship operating system. There are a few other operating systems they offer for the platform. It's not just any big clunky computer. It's not just any dinosaur. Mainframe is a very specific type of machine. It's built to handle huge amounts of I/O. So like, for example, like all the credit card transactions that happen every day. If you used a credit card today, you interacted with a mainframe. They're built for reliability, availability, and serviceability. These things are like utilities. Like they are made to not fall over. They usually have insane backwards compatibility. I mean, IBM Z hardware will run stuff that was like written in the 60s with very little modification. Batch-oriented is the other big thing. They write really complex batch jobs so that you can do things like shove like 1 billion credit card transactions, run them through a batch job, have them all processed and laid out without people having to constantly come in and interact with it and interrupt processes. And they're always mission-critical systems. That's one of the reasons why mainframers won't let you touch them. A quick note about AS400, which it hasn't been called that since the 80s. The real name for the platform now is IBM I. It's not a mainframe, but it's what's it called, a mid-range. It's like the next tier down. You still see them out there. I've hacked on them before. There's actually a lot of good work on them too, but they're out of scope for this as well. So what isn't a mainframe? It's not freaking legacy, so just get that out of your freaking little brain. And it's what you constantly hear when you talk about mainframe security. IBM Z still makes a couple $1 billion a year for IBM. It ain't going anywhere. It's still the backbone, as I mentioned, of things like finance, airlines, the insurance industry, governments, lots of big customers. Granted, there's not a lot of growth. Most of your mainframe customers have been mainframe customers since the 60s and 70s, but it still makes a lot of money for IBM in licensing and hardware replacement and updates. It's still actively maintained. It's not legacy. My research director even fell for this. She's like, if you drop OD on a mainframe, is like every mainframe customer going to be hosed? And I'm like, no, they're updated. Like they get patches, okay? It's like if I drop OD, IBM will fix it. Don't worry. In fact, the next major version is ZOS 2.4. That'll be coming out in this September, and it's about every 2-year cycle they release a major version. And it's been updated to run modern stuff. They run web apps, it runs Java, it runs SQL, and it also runs COBOL apps that were written in the freaking 60s. And IBM likes to push it into new things like cloud computing and blockchain and all that trendy stuff. Just because ZOS is very conservative in its design, I mean, you can tell that this is one of the first operating systems ever written. It's a direct descendant of OS 360, which was the first mainframe operating system. Just because it's very conservative in its design and style, and just because it has that nutso backwards compatibility, don't confuse that for legacy. And when you think of a mainframe, you probably think of something like this. You think of like magnetic tape reels and blinky lights, you know, like the stuff on my t-shirt here. In fact, this is my great aunt Fran, who worked for Amex. She retired from there several years ago. That's her in the 70s on an IBM System 370 mainframe. But nowadays they look like this. They look like a giant gaming PC. I mean, these things are beasts. You know, it's like the size of a cafeteria refrigerator. It can have like 170-ish processors and co-processors, like 320 gigs to 32 terabytes of RAM, I believe. You know, it's a 64-bit, like 10-core architecture for each chip. I mean, these things are beasts. I screwed up. I didn't have the background on the monitor view, but I have a background from an anime called Sword Art Online. And in one of the movies of that, they show like it's about like a fictional like online game, and the mainframe that runs the game in the anime is a straight ripoff of a Z14 mainframe with its like little like you know, that angular like blue lighty stuff. So one thing I want to teach you is kind of how to speak mainframer, because they have a very different lingo from Windows and Unix admins. They have their own language. So one thing right off the bat is that mainframes don't speak EBCDIC. Or sorry, they don't speak ASCII, excuse me. They don't speak ASCII like everything else in the world. They speak EBCDIC, which is a proprietary text encoding format that IBM has used since the 60s. Another thing you'll talk to mainframers, you'll hear about LPARs. There may only be one actual mainframe box in your data center at your company, or maybe just a handful, but it'll look like you have dozens of them because each mainframe will be busted up into logical partitions, or LPARs. A colleague I used to work with named Austin Robertson, who was a mainframer turned pen tester, he compared it to VMs on an ESXi box, but yes and no, because they're not really VMs. It's just that there's so much RAM and so many processors around, you can just run multiple OSs simultaneously on these things. And most places will have I think it supports up to 70 LPARs on a box, and it's all managed in firmware, who gets what resources and everything. And then a cluster of LPARs will be clustered together into sysplexes. So in an environment, you might have production LPARs or a whole production sysplex, and you might have a dev or QA sysplex and LPARs. It's usually on the same box, or it might be multiple mainframes that are networked with fiber optic. It can kind of span boxes. IPL just means initial program load, and that just means booting the mainframe. Storage is kind of confusing in mainframe world because it refers both to what we would call storage, like hard drives. DAS-D is the acronym they use for hard drives. It means direct access storage device. But it also means memory. So if you hear about virtual storage, that means virtual memory, way in the Windows and Linux world would call that. And you don't have files, you have data sets. The mainframe file system is very flat. You don't have a lot of nested directories like you do in Windows and Unix land. Most things are, to kind of organize it, they're kind of do a dotted notation, kind of like Java or reverse DNS. So the first part will be the high level qualifier will be the first part. So if it's a system file, it's usually sys1 dot something. Or if you as a user, when you create a new data set, it'll usually get appended with your username. So if you're user1 and you make a file called job.jcl, it'll become user1.job.jcl. Those are what you call sequential data sets, which are kind of like normal files, it's just a file. And then the equivalent of a folder is called a PDS, or a partitioned data set. And in this example, you see that it's user1.pds, and then in parentheses, you'd put the members, the contents of this directory. But you can't nest PDSs. You can only have one PDS with stuff. You can't have nested inside it. So it's not like a Windows or Unix file system. It's very flat. Almost everything on the mainframe is a job. Even if you have the HTTP server running, it's running as a started task or a job. And everything's managed by the job entry subsystem that controls all the batch jobs that get processed, all the batch jobs you submit. And then also you'll hear MVS used. MVS is, the mainframe operating system has changed names about a dozen times between 1964 and now. And for most of the 70s and 80s, it was called MVS. And so you'll still hear people refer to the MVS file system, or I uploaded a file on FTP to the MVS side. So when you hear MVS, that just means the mainframe OS. It's just an old-timey term for it. The way you interact with the mainframe is with TN3270, what we call the green screen. It's actually a modified version of Telnet that speaks EBCDIC instead of ASCII, and it emulates an IBM 3270 terminal. Kind of the same way when you use SSH or something, you're emulating an old VT100 terminal, technically. VTAM, don't kill me mainframers, but I'm gonna simplify and say VTAM is kind of like your portal. When you start your TN3270 session and you hit port 23, you'll get the VTAM screen and it'll ask you what you wanna do. Do you wanna log into TSO, or do you wanna log into a Kix app? It does a lot more, but for our purposes, it's a portal, so I won't go into too much depth on that. TSO is basically the shell. It's the command line interface for the mainframe, and I'm gonna show it to you here in just a minute with some demo videos. ISPF is kind of like the mainframe GUI. It's very ncurses-y-like. It's in the terminal. You can actually click around your mouse, but it's text-based. And then every mainframe has Unix inside it. It's a mandatory component. It was IBM's cheap and dirty way of porting TCP into the mainframe in the 80s, which Windows kind of did something similar. Windows ripped off BSD's network stack in order to have TCP. IBM was just well, let's just put a whole freaking Unix inside it. So it's a little OS. It's much like WSL is in Windows 10. It runs as a subsystem. It can talk to the mainframe, the MVS file system. You can copy files down to Unix. It can interact with it in certain ways, and you'll see that in the demos. Yeah, I'm not doing it justice. I know mainframers are going to be fucking shaking their fists at me, But anyway, mainframe culture is very different than Windows culture. Mainframe, most of your mainframe installs are very old. I mean, people have been mainframe customers, have been customers since the 60s and 70s. They have their own culture around it. They'll even use their own terminology internally that like IBM doesn't use, so it can be kind of confusing. And mainframes kind of want to be decentralized and centralized at the same time. You'll generally only have one or a handful of large boxes, but like I mentioned, they'll be divvied up into LPARs, or if you run ZVM, which is another popular mainframe OS, it was actually the very first hypervisor created in the 70s. It might have like 1,000 like Z Linux instances running inside of it. So it kind of wants to be in the center of everything, but also kind of wants to be distributed with a bunch of different instances too. Security is not exactly built into ZOS. ZOS has a very rudimentary like dataset security features to it. But almost everyone buys an external security manager. The most popular is RACF, which is the one that IBM makes, and then Computer & Associates owns two others, ACF2 and Top Secret. I'll talk about RACF. It's the most popular. It's got the biggest market share, and it's the one that I have available to me to test. So this is the one I'll be covering. And RACF has a database that basically holds everything in it. It holds a table of all the file permissions, who has rights to what, all the different profiles. It holds the password hashes. It can hold cryptographic keys. You can use the rvary command in TSO in order to find out like what the name of the database dataset is. There's no real concept of a root or an admin like super user in mainframe world. The closest thing is like if somebody has the special attribute in RACF, which just basically means they can change anything in RACF. So if you have special, you can give yourself access to every data set on the mainframe. Historically, they've had really shitty passwords and really bad like DES hash functions. I mean, it's like LM level bad. They've gotten better. They now support longer passphrases. They support a new algorithm called KDF AES, which is AES based for hashing passwords. They even support like RSA tokens and stuff like that. But don't be surprised if you go to a site and they're still using like 8-character passwords that are all uppercase and only allow like 3 special characters to be used inside them. Because mainframers also tend to have a IIABDFI. If it ain't broke, don't fix it. They tend to have that kind of mentality sometimes. Like, well, it's working, don't fuck with it. On the mainframe, your big programming platforms are still like assembler. A lot of people still write stuff in like 64-bit big endian Z architecture assembler code. COBOL and PLI are still out there. Fortran seems to have kind of PL1. Sorry. See, I'm already getting correct. I'm getting the actually from the mainframe nerds. Fortran seems to have fallen off in popularity because it's not even referenced on some of IBM sites, but Fortran's probably still there. And then through USS, Unix System Services, you get Java and C and C++. Your big scripting languages, the biggest is JCL, which is really much more than the scripting language. Pretty much everything is done with JCL, what they call job cards, which you could think of like a script. They'll tell like a program how to run, what to do with the input, what to do with the output. You'll see some examples in a minute. CList, I would liken it to like DOS batch files. It's just like a list of TSO commands with some kind of primitive like loops and stuff. It sucks. Use Rex instead. Rex is a much more feature-filled scripting language. It's much more like Perl or Python, and most of the tools that like guys like Phil Young is like the god of like mainframe hacking. He actually helped me with this presentation and reviewed it for me. So big ups to Phil. I'll thank him later in the acknowledgement section. Him and most of the guys that do mainframe hacking write their stuff in Rex. And then you also get shell scripts and Perl and stuff through USS. And Rocket Software, which is a big mainframe software vendor, they've ported Python and some other tools, which you can get for free off their website if you sign up. These I won't cover as much because it's a whole subject to itself, is CICS and IMS. So CICS stands for Customer Information Control System, and that is basically like mainframe apps so that you don't have to teach normies how to use TSO and log in and stuff. If you've seen like funky like people in like look like DOS prompts and they're in these like green screen apps like at your DMV or maybe like at an AutoZone or something, it's very likely it's a CICS application they're interacting with. If you can see this example, like this is just like a form field, and all somebody would do is just click around, fill out the form field, hit enter. It's just a purpose-built application. A lot of the security is actually relying on the TN3270 protocol to behave, and a lot of it is what we would call client side. So a lot of it sucks. It's a subject to itself. If you're more curious, Dominic White and Ayub El-Asal have done some great work on this. I have links in the resources. So after this talk, if you want to download it from my Google Drive, I'll have the link on my blog. You can go see all their presentations. It's a really fascinating topic on its own, but I can't really cover it all. So now some demos. So let me show you all. I just recorded it because I'm not going to tempt the demo gods. I'll show you guys a little demo of what TSO and ISPF look like. So here, alrighty. Okay, so here I'm using X3270, which is just a free Linux X11 based terminal emulator. It runs in Mac, you can run it in Windows, and I'll go over some of the other options for you depending on what platform you use. So here's the first thing. I'm going to go and I'm going to connect to the IP. The default port is 23, just like Telnet. Now pause it real quick. You see here, this is VTAM. So you're hitting the VTAM screen, and it's telling you, hey, you can do this. You can do login and then your username ID, or you can enter TSO. If I had Kix or anything installed, it might say, oh, enter this to enter Kix 1234 to hit this Kix region. So if you're not sure if you're on VTAM or not, you can just hit the command IBM test, and it'll print a little test screen. So if you're hitting an app and you're not sure whether it's VTAM or Kix or something else, you can just do that. And here I'm going to use the logon command, if it works. There we go. And there's my username. So this is a mainframe. It's part of Master of the Mainframe, which is an IBM program for like college outreach. You can get a free account on it. I'll just tell you the details later. That's a very common username scheme you'll see for what we call TSO IDs. If you work at a place and your username is called a TSO ID, this is why. It's because you're a mainframe customer. And a lot of time it'll follow a format like TSO's requirements are you have to be 7 characters, and it can't start with a number. So I worked at a place where our login IDs even for Windows was A and then a 6-digit number. Or I worked at another place where we used TSO IDs and it was like your initials and a 4-digit number. That's just like one of the old like limitations of TSO. So I'm going to log in here, and so I hit the login screen here. I just enter my crappy password. It'll go through some boot messages and stuff. It'll also broadcast messages, kind of like on like SSH if you log in. And here you'll get to see some Epsidic art in a minute. Yes, instead of ASCII art, there's Epsidic art. Mainframers love Epsidic art. You'll see it a lot when you look at like some of the mainframes out there. So there's the Master of the Mainframe logo with a little like world map. And so now we're going to get into ISPF here. Okay, I'm actually going to exit out of it, and then I'm going to show you what TSO looks like. So this is the shell. So this is TSO. It has that ready prompt like a freaking Commodore 64. And TSO sucks. Like TSO is like for very low level stuff. It makes the command exe look good. Most mainframers do their work in ISPF, but here I'll show you some commands. Like there's the list user command, which is kind of like running ID. It shows me all my access rights to stuff and my name and things. You can also do shortcuts, like you do LU instead of list user, and then I can give it a user ID. So I gave it my own, but because like by default, I'm not allowed to view other users' profiles. Like if I put somebody else's username, it would just tell me I'm not allowed to do that. But I do the same thing, and here I'll tell it to specifically tell me my TSO and my OMVS rights. So you can see OMVS right there. I can see that like that's my UID on the system, and there's my home directory, and then whatever shell I'm supposed to use when I log into OMVS. And now I'll run profile, which is kind of like bash RC. It'll do things like say what high level qualifier is your default when you like run a command to list data sets. It has the ping command. So there's even like network stuff ported over, like ping is in there. There's no real like ifconfig, but instead what you use is you use netstat home, which I'm going to do right here. And now I'll show you all your interfaces that are installed. And when you get to the other thing, TSO sucks. There's no like job control, there's no history, there's no like scroll buffer. When you hit the bottom of the screen, you get the 3 asterisks and you have to hit enter, and then it'll clear the screen and start at the top again. Yeah, it sucks. Like I said, TSO sucks. That's why everybody does everything in ISPF, because ISPF is much nicer. So there's list_cat, which is kind of like the ls command. It'll list, and by default, I have it set to like prefix everything with my username. So when I do list_cat, it only lists the files that belong to me, that have my high-level qualifier, which is my username. So there I've got a bunch of stuff here. I've got some scripts. I've got some JCL stuff. I've got different system files. And you can also abbreviate that to list_c. List_ds will actually just show you an individual file. Like it'll just show you some of the information like the block size. Making new files in TSO is also like a tremendous pain in the ass. It's like defining C variables. You have to assign like sizes and shit. It sucks. Or here I'm listing out a PDS, and I use the members option in list_ds in order to like. Oh, did it jump? Look, it kind of jumped over. Hold on here. Okay, let's do that again. Okay, here I can use del to delete a file. I can rename files. Making new files sucks. I think I show a brief example of just making a new blank file. So there, she deleted the unix.jcl. And there I'm going to rename test.jcl to unix command.jcl, just to show you, you can move stuff around. It's not as nice as Linux, but it'll get the job done. Come on. Oh yes, you can't cat files. It sucks. You have to use the line editor in order to view the contents of a file. So here I'm going to use edit on the command.jcl file I just renamed. And you'll go into line editor mode. And also you tell it what type of data set it is. So CNTL just is what they use for it's a control file or it's a JCL. There's also like text and there's a couple other options you can enter to tell it what kind of file you're editing. And then I have to use the list subcommand in edit in order to list the contents. And that's what a JCL job card looks like. You'll see it in more detail in the ISPF video. So I do end no save to just quit out of it. Let's see here, I'm editing something again. I don't even remember what I did here. Oh, okay, here's a Rex script, which will look a lot like more user-friendly. So I tell it's a text file, because Rex is just treated like text. Okay, hit enter, and I list it out. And here's your Rex file, which looks a lot more familiar. It looks like a programming language you might recognize. Usually, by common convention, you'll do like a C++. Well, I don't know. I call it a C++ style comment, but Rex might have done it first. I don't know. So you put Rex, and then here's a comment. This is a script that just lists all the Unix users and their like UIDs and home directories and stuff out. It's one I kind of modified from an IBM example. And then I just end no save. And here's me executing this Rex script. So you do exec or ex, you can abbreviate ex, and then you put the name. So here it is. It's going to generate a lot because I'm on a big ass mainframe. So here's another thing: is your equivalent of Control C is the PA1 function key, which there's a lot of funky function keys in TN3270. That's why all the emulators have like a little virtual keyboard, so you can get all these like weird ones. The PF ones will usually be mapped to your function keys on your keyboard, but like PA1 and PA2. They're mapped to something in X3270 I don't remember, so I just use the virtual on-screen one. And that's basically like the get me the hell out of here key is to bash PA1. So you'll see it'll let me kill out of that long listing. I just entered HI in order to exit out. So here's allocating a new data set called test. And the fastest way to make a blank one is just to make a test and make it look like this other file I have named. Oh, I screwed it up because there's nothing named test.jcl. So there's an error message for you too. And all these like obscure error codes, if you just Google them, they're all up on IBM's website. You can see what they mean. It may help you, it may not. Sometimes they're a bit obscure. So there I allocated a new data set. And it's just blank. That's just basically like the equivalent of running the touch command. Okay, I think that's the end of that demo. Okay, and here I am, I'm logging off. And so now I'm out of that. So next up, let's see what ISPF looks like. ISPF is much nicer to interact with. It holds your hand a little better. So here I am at VTAM again, and I did the generic TSO, which will let me enter a username, and then my password. Back in, okay, and I'm back connected. So this is ISPF, which gives you this nice little number-driven menu. You see everything there. As I said, it's much more user-friendly. So at the bottom, they have other functions. This install has been nice enough to define little shortcuts to common things like Unix or SDSF, which you'll see in a minute. That's not default. Somebody's been nice enough to do that. You'll see every install will be a little bit different in how it's laid out. It all kind of depends on the history of the company and how the mainframers like their stuff. You can run TSO commands in there too. If you do TSO and then list C, you'll see it'll run the list C command for me, and then once it's done, go back to ISPF. So here I went to 3, which is utilities, and I'm going to go to 4, which is DS list, which is just for listing out data sets in the file system. So here the DS name level is my username, and so you can see, just like running list C, you can see all the files that belong to me. And here I'm going to edit one. So I went real quick down here, and in this column, I put the letter E and hit enter. And that's telling ISPF, I want to go into the ISPF editor and edit this file. So you get one of these little messages, you just hit enter and ignore the shit. Come on, there we go. So here's a JCL job card. So this is one that, it's just a simple one that it runs a program called, this very, very easy to remember name, IKJEFT01, which is basically just a JCL program. It just says run TSO commands. So here's this is the name of the job, which I named it TSO info, and then there's some like control information so that you can prioritize jobs and stuff. This is the name of the step because JCL jobs can have multiple steps. I'm kind of defying convention because as a good user, you're supposed to just use your username and then another number, but I did it to be a little more readable. So this is just saying like this step, I'm going to run this program. I'm just doing this is controlling like the input and output stuff. It's just going to print to like a file that I'm going to read through the SDSF manager. And I'm just going to run these commands. So here I'll show you how to edit it. So let's say I want to delete that. I just go there to the line number and I write D and enter and it deletes it. And then I'm going to I to re-enter a number. And you put a new line in there and I'll re-add it and hit enter again. I'm done. So I'm going to go save it. And then I'm going to submit it. And I'll submit it to be, oh, hold on, you almost missed it. Let me go back a little bit. At the bottom of the screen, you can barely see it. Oh, there we go. You can see down here it says job submitted. So it gives me a job number so that I can go find out like when it's completed and what input or output it made, or if it screwed up and generated an error for me. So I'm going to exit out of here. You can use the F3 command, will like just send you back. That's also kind of like to get me the hell out of here. Just hit the F3 function key. And so now I'm going to go to SDSF. SDSF is kind of like the task manager in Windows, but on steroids. So I'm going in there, I'm going to ST to view job status. So I'm going to enter my job here. I'll do a question mark in the column, enter, then system, syst TS print, and you can see the output of my job, which it just ran TSO commands. It ran LU. It then ran, what did it run down here? It ran netstat home and some other stuff. So when I'm done there, a lot of times F4 will just be a generic key to send you back to the start of the ISPF menu. So now I'm going to edit another one, and this is another JCL job that will run Unix commands for me. And so this one, it runs another program called BPX batch. About anything that says BPX, I don't know what that actually stands for, but it always refers to Unix, because you'll see like BPX super user is like the RACF permission to like let somebody be super user in Unix. So this one, I'm just feeding it a parameter, and it's going to run ID and then netstat H in order to see like my interfaces. So here I'll show you a little shortcut so I didn't have to like enter so much text. I can write reset to get rid of those error messages. Now you submit and then colon, and then it signifies I'm going to feed it another ISPF command. So I'm going to do equals SD, which means go back to the first panel of ISPF and run the command, because the SD command is defined there on the first, like the home page of ISPF, if you want to call it that. And then another colon saying, hey, once you're in SDSF, run ST to go view job statuses. So that saves me some steps. So I'm right back at this page now. And so I go find that Unix job. I go take a look. I go view it. And there you go. See, I run my UID and GID info because I'm running the ID command, and then netstat home info, so I can see like my interface and everything. And I go back to the home page of ISPF. And now we're going to take a look at Unix. So you can get to Unix via the OMVS command in TSO. So also you'll hear people call Unix OMVS. It stands for like Open Edition MVS. So that's what they called it back in the 80s when they first ported it into the mainframe OS. And you get this little prompt here. So I can do it, say I run an ID command and show the uname. It still thinks it's OS 390, which is the 90s name for the mainframe operating system. I don't know why they haven't updated that, but I can run ls and like see what's in my home directory, do all that stuff. And you can also get to this through SSH usually, or older environments might still have like telnet or even like rlogin or something in order to interact with Unix. Pro tip is define your terminal variable as like do like export term equals VT100, or else like you won't be able to use like VI or clear screen or any like the nice like terminal commands, because it won't know, because like, you're on a modern system, like the terminal variable, if it would be like xterm 256 or something like that, it won't know what the hell that is. You got to tell it's a VT100. And here what I just did is I just ran I just copied a file. If you see here, this is how you copy files out of the OMVS side. You have to usually you do it in parentheses. You do slash, kind of like almost like an SMB share. And then you do the name of the file, and you copy it over to Unix. And so you see here, it was just a Rex file that just says hello world. And then you can just chmod +X to a Rex file and just make it to an executable, and it'll run it'll run in OMVS here. So that's what I'm doing. I marked it executable, and I'm just going to run it, and all it's going to do is say hello world. You can copy files from Unix back to MVS, but it's a little more complicated because you have to do all this stupid allocation shit, like tell it like the block size and things like that. So generally, the way I copy files is I just use FTP because FTP handles all the EBCDIC translation and all like the size allocation shit. So I just write scripts in like Sublime Text and then just FTP it up because that's way easier than fucking with this thing. And here I am. I do the X command in order to exit. And all it's doing here is it's basically got like it's got this file spf log1.list, which is kind of like your command history in ISPF. And I just tell it I don't want to save it. I'm just going to delete it. So I'll do the 2 option and hit enter. And then I'm out. I'm back at the TSO prompt, and then I can log off, and I'm done with the system. Okay. Now we'll resume here. No, hackers in the mainframe. So I also want to address overcoming some organizational obstacles to getting mainframes pen tested. My first encounter with a mainframer was being screamed at over the telephone by an old man. I worked at a large insurance company, and we were exploring privileged identity management. So we wanted to have some kind of solution like our, what's that one, ArcSight or one of those ones that like can like manage all your root accounts and like domain admins and stuff. CyberArk, yes, thank you, audience. Yeah, we were looking at like CyberArk and other stuff, and we knew it had mainframes, and at the time I didn't know jack about mainframe shit. So I was on the phone with these mainframers with a guy named Kyle who was in our security team. He had been in IBM before, and he spoke their language. And we're telling them like what we want to do, and I mean I don't even know like what the equivalent of a root is on a mainframe or anything. And this guy just starts like laying into us over the phone about how security is going to jack his stuff up, and if he can't get into systems when there's a critical outage, that like we're going to lose billions of dollars every second lost transaction, blah 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 blah. Like for about 5 straight minutes, this guy is just yelling at us, and I'm like the phone on mute because I'm cracking up, and I'm like I can't believe I found like a specimen that's even surlier than like an old Unix graybeard. Like there. So the problem with a mainframe is the mainframes are simultaneously this, but also this. It's the most highly secured system in our data center. Like it's never been hacked. It's never going to be hacked. It's got all the latest security features that IBM has to offer. But simultaneously, it's my pressy fresh baby. And if you so much as port scan it, it's going to fall over and we're going to lose $1 million. So obviously, obstacle number 1 to mainframe pen testing is the mainframers themselves. But here's the thing, mainframe knowledge is a lot more guarded and it's a lot less accessible than Windows and Linux because you can't just go buy ZOS unless you have like $1 million sitting around. It's not like Windows or like Linux where it's like freely available and there's lots of people that know that stuff. Mainframers are very steeped in their own culture. As you see, they speak a totally different language than like Linux and Unix sysadmins or Windows admins. They skew a little older, but IBM is trying to fix that. They've got a lot more college outreach now because they realized that like half their workforce was about to retire because like a lot of mainframers are baby boomers. So they kind of realized, oh shit, maybe we should actually start teaching like college kids how to like program mainframes. As I mentioned before, they kind of have a if it ain't broke, don't fix it mentality. Sometimes they'll omit doing security things because it's like, well, everything's working fine, let's not fuck it up. They can be incredibly surly, as I learned. But the key thing to talking to them is assure them that you respect their platform. And one of the easiest ways is learn this lingo and talk to them in their language. You know, show them that you respect how important it is to the business. And you're not there to dunk on them. You're not there to just make them look like shit. You're there to make the security better. And you want to make the mainframe a better system. You're not there to just like, ha ha ha, the old fucking dinosaur, you know, has shitty passwords and everybody can own it. You know, make them feel better and get them on your side. It'll make it a lot easier. Obstacle number 2 is a little something I call the fear. IBM is the master of fear, uncertainty, and doubt, FUD. You know, you've all heard that acronym. IBM pioneered it. Actually, there's a guy named, I can't remember his first name, but Amdahl. He left IBM to form another like mainframe competitor, and he talked about IBM used FUD, fear, uncertainty, and doubt. Gene Amdahl. Yeah, sorry, Gene Amdahl said FUD because like IBM would always like if customers were thinking about moving to a different platform, IBM would sow the fear, uncertainty, and doubt. Like, oh, you don't know about those guys. It's not tested. You know, IBM is reliable. Nobody got fired for buying IBM. You know, so you know, don't risk it on these unknown, new, Johnny come latelys. So that's the biggest obstacle is the fear because the mainframers know everything about the platform and upper management knows freaking nothing. They don't know anything except what the mainframers tell them, and the mainframers have told them if you poke it, it's going to fall over and we're going to lose $1 billion. So of course they don't want to they don't even ask for pen tests against mainframes. It's an inviolable system, and you do not touch it. But the truth is, it's just a fucking computer. And at that, it's a computer built for ungodly availability. I mean, you have to try hard to ruin a mainframe. It's not easy. I mean, part of this came about, I think, in the 90s. There was actually, I've heard the story told of ZOS, and I've heard it told of AS400, that one of them had really long time to live on waiting on Synax, it would send a Synac and it would have like a days long TTL. So if you did a Syn scan, you would DOS the TCP stack. So but that's obviously been fixed because there's mainframes on the internet. Phil Young, the soldier of Fortran on Twitter, the big mainframe hacking guy, he has a whole catalog on Tumblr of hundreds of mainframes he's found online. And obviously if that happened, those things would be getting knocked over multiple times a day. But no, they're very resilient. And also, like any computing environment, they have dev and QA LPARs, or even sometimes even entire sysplexes. They'll have a dev sysplex and they'll have a QA sysplex or a prod sysplex. And they have ones that mirror prod, just like any good environment. So yeah, sure, you don't want me to test on prod, I get it. Let me go test the QA version that mirrors prod, and then let me see how RACF is set, how are user accounts when they're provisioned, what kind of rights do they have, can I do nasty stuff? Assuage them that way. Let me mess with the QA system. I won't make you bankrupt, if I fuck something up there. And then maybe a more minor one is hubris. That's kind of that first part where mainframe is Fort Knox, and you can't touch it. It's the most secure system in the data center. They can be very secure. That's not the joke. You properly configure them, they're a very secure platform. But mainframes do get hacked. The most famous one that we know of was Anakata. Was one of the guys that founded the Pirate Bay torrenting site. In 2012, he got pissed off at his native Sweden, and he went after a bunch of companies there that were running mainframes. He got into one called Logica, which was a contractor to the Swedish and maybe even I think also the Danish government. There's a lot of country interlinking here. He hacked into their mainframe, and he just found it and just did research on his own with an open source emulator, and figured out 2 O days in order to own the mainframe. And then he also hacked a bank in Sweden. He got $5,000 out, and then got greedy and tried to do a 10,000 euro transaction and got busted there. And then there was a third company in Norway who got his mainframe hacked that they haven't proven it was him, but I think he's going to be on trial for it soon. So they highly suspect he did that one too. IBM is very much into security via obscurity. They don't like publishing stuff. They publish CVEs after the Logica breach because the EU made them. The EU was going to sue them if they didn't make a public CVE for the hack that led to it. And even if you drink the IBM Kool-Aid and you believe this is the most secure system and it can't be hacked, well then what's the harm in letting the pen tester verify it, right? So use their words against them. So obviously you want to know how to hack mainframes. That's why you're here, right? So let me organize this like a pen tester red team. So let's start with our initial recon. Just like anything else, nmap it. I would recommend doing all ports. Oh, that's another one that surprisingly few people know is if you do -p-, that scans all 2 to the 32nd. Where the fuck? I don't remember that number. 65,000 and some change ports. It's easier than remembering that number that I never remember. Because you'll find stuff running on non-standard ports. Port 23 will be there. A lot of times they might have apps hosted on iterations 1023, 2023. Just scan every port to be sure. If you have access to an internal knowledge base, say it's this this is an internal pen test or maybe a red teaming scenario, and you can get to the SharePoint or the Confluence, or if they have internal wikis, go searching for mainframe stuff because the terminology is unique enough. You can find results really quickly. You search for stuff like LPAR or TSOID. Attachmate and Rumba are two commercial TN3270 emulators that are way too expensive for me, but you can find stuff about them that might tell you where the IPs are or what the naming scheme is. Another red team scenario, if you've compromised a host, take a look at the file system. If they're a mainframe user, they might have FTP scripts that they're uploading stuff to the mainframe's FTP server, and maybe it's got the password and username stashed in it. You might look at their config files for their terminal emulators, things like that. And so the stuff you want to know is you want to find out LPAR names or IPs. You might look for Kix region names if you're hacking those. You want to find out what the username convention is so you can start enumerating. Find out what the password convention is. And of course, if you can find it, just get some freaking creds. So here's a typical nmap scan. I don't know if anybody see this, but here's some pretty typical ones. This is that master the mainframe one I was doing earlier. Okay, I can't get my mouse. So port 21's open, and it's identified it as OS 390 FTP daemon. So there again, it's OS 390, which it hasn't been called that since the 90s, so I don't know why it's still that way. SSH is open. Port 23, it's identified as TN3270 IBM Telnet. 1023, you can see here, that's another one, another TN3270. It's got DB2 open on it. It's got IBM Explorer for ZOS, which is another like user product. That's kind of what a typical nmap of that would look like. And how do I get creds? So there's a lot of different ways, and that's one of the things about mainframe hacking is there's not a lot of routes to go from zero access to owning it. You gotta find creds some way along the way. So that's one of the better things about IBM. So one thing is if you're in an internal environment and you can do ARP spoofing and start or man the middle stuff and sniff traffic, lots of the traffic is unencrypted because TN3270 by default is telnet. It's not encrypted. You can run it like TLS encrypted on usually it's on port like 992, but maybe about half of shops actually do that. As I mentioned before, you can steal them out of like config files or like FTP scripts and stuff. You could even phish them. Phil Young has a tool called Set in 3270, which is like his social engineering toolkit, where he'll let you put up like a fake VTAM login, and it'll actually act as a proxy. So if you can trick people to go log into it, it'll proxy the connection to the real mainframe for you. So you'll get their creds and you can man in the middle of their traffic. Try reusing, because I worked at a place where they had to sync passwords between every system. So all the Linux, Unix, Windows, mainframe all had to use the same password with a password sync solution. And we had like horrible password rules as a result. Like it was like 8-character limits, and you could only use certain special characters. So if you've already stolen some Windows creds and they look like they'd fit the mainframe password convention, try them out. And if they're syncing or not, maybe users are just lazy, so they don't want to remember 2 passwords, so they'll just set their mainframe password to be the same as their Windows one. You can brute. They are weak, and like I said, a lot of times they might be limited to like 8 characters or something, but do it with caution. By default, RACF does not set a password limit, but everywhere basically sets like 3 attempts, 5 attempts total. Like if you do 3 or 5 bad attempts in a row, it locks you out. It's not like Windows domains where it's like you spray for passwords in Windows. You can do like 2 or 3 an hour and just wait for kind of the timer to reset and then try again. It's not like that in mainframing. So Phil recommended maybe trying like one like seasonal password, like maybe try like JUN at 2019, something like that, and maybe trying like 1 a week. So very slow. Most people don't have that kind of time. So yeah, password spraying unfortunately is not a valid attack path really, and that applies to logging into TSO, SSH, even SU. I actually tested that out, and like if you get on Unix and you try to SU to another user, it'll count against RACF and it'll lock the account if you try like 3 bad ones or however they have it set. What up?
Password spraying in the other environments is perfectly.
Exactly. Yeah, you can always still, like I said, if they're reusing passwords, you can always password spray Windows instead, and maybe they're reusing the passwords between them. Once you're on, like any good pen test, start enumerating. There again, like I said with nmap, use the -p flag. There's plenty of nmap scripts to enumerate stuff. Phil Young wrote most of them, so you can enumerate different like VTAM application IDs. Logical units, I won't really get into that one. That's more like when you connect to a terminal, you're assigned a logical unit number, and sometimes you can just like tell it a different number and it'll give you somebody else's session. I think that's pretty rare nowadays. TKIX transactions, or TSO user IDs. TSO is nice enough to let you know that a username is not valid. Now, it might mean that the user exists, but they're not allowed to log into TSO, or it might mean that the username doesn't exist. But if you put in a username that's not valid, before you even have to enter a password, it has a little error message that says right there, it says user ID fake, not authorized to use TSO, if you can see my little screenshot over there. So it's nice enough to let you know, so it makes enumeration really easy. So if you got creds at this point, try logging in. One caveat is you may find users that they may have access to TSO or they might have access to Unix, but they might not have access to both. It depends on how the user was created. They might not have been created with a Unix UID and an OMVS access. TSO is also nice enough to let you know that if you're logging in, that the user with that name is already logged in. So it gives you a little bit of OPSEC, but also by the same token, if you log in and then the legit user comes along and tries to log in, he'll see that somebody else is using his username. So SSH and FTP don't have that limitation. You can have multiple instances logged in at a time, so it's a little stealthier that way. You don't risk getting caught. And FTP on ZOS can run JCL jobs. You can set it to a mode where you can upload a JCL script and it'll just run it under the whatever context you're logged in as. So it's basically RCE as a freaking service. And Phil Young has written like 4 or 5 different tools to exploit this. And the most easiest one is a Metasploit module, which you can use, and it'll just give you a reverse shell back into the Unix environment. Another service you'll find on mainframes is called NJE, which is Network Job Entry. And it's a way for different LPARs or sysplexes to send JCL jobs between each other. All you do is when you write your JCL job card, you write the name of a different node. All you need to know is you need to know your own node name, you need to know the node name of who you're sending to, and it's all defined in a config file on the mainframe file system. And then you have to have a valid username on the remote end that you're connecting to. So you have to have and actually it doesn't have to be the same person. That's another thing you might exploit is that the same username might be 2 different people on 2 different mainframes. But if it's valid, NJE will accept it. So you can brute the node names. They can be configured to require a static password. You can brute that too. So it's another way of just getting RCE as a service. And also it's good for lateral movement, as I'll talk about later. Again, I won't go too much detail about kicks because it's a subject to itself, but kicks can also be a foothold. It might have a bad default transaction enabled where you can also upload JCL and run it, and then you get a TSO account as the kicks service account. But there's more tools for that I won't really talk about here. Also on the other side, on Unix, a lot of them run WebSphere and Tomcat. So same as if you found it on Linux or Windows, if the manager page is available and you can guess the password, you can upload a WAR file and get yourself a shell. You can try different things run Nicto against it. Chad Rickensrud, another luminary in the mainframe hacking world, he's done some work around Java deserialization attacks against web servers running on mainframes. You might even see older ones that have these crappy CGI apps that just basically have command injection in them. That's actually how Anaconda got onto one of the mainframes he hacked. It was just command injection in a CGI script. And then DB2, I feel DB2 is really underserved on the mainframe. It's gotten a lot of attention when it runs on Unix and Windows and stuff, but that's something I think I'm going to research more in the future, especially around stored procedures, because I've seen some interesting stuff with DB2 on the AS400 platform, being able to run rec scripts and stuff. And I want to do more research on this because I feel it's really underserved on the mainframe platform. So it's a space that needs more attention. And you may find other things out there. You might find NFS or SNMP running on it, MQ servers. Just look. A lot of stuff runs under the Unix side of the house. So once you're in, you may not need special. If you've got a sufficient user account and your goal is just to steal credit cards or something, you might get a user account that has access to that stuff, and you might be able to pull those data sets and exfil them and go. But I know you're not here for that. You're here to own the sucker completely, right? So you want to get special and be the closest thing you can be to a super user on the platform. So like any pen test, it's time for even more enumeration. And Phil Young has a great script called enum. It's just a rec script you can run, and it'll just dump a bunch of data about the system. It's a great one I recommend to run and see what kind of nasty libraries might be installed or what kind of file permissions are out there. Pro tip for exfilling, I would use FTP, the old secure copy command, or in the TN3270 emulator, it has a built-in file transfer function called $file that you run from TSO. I would recommend using those. I have not had great luck with SFTP. If I use the SFTP command, it usually fucks up and it doesn't convert properly from EBCDIC to ASCII and vice versa. But normal FTP, or for some reason the SCP command, which just uses SSH, I don't know why it works and the others don't, but oh well. So there are a couple different unique privilege escalation routes you can do on the MVS side, and I'll talk about the Unix side too. You can try checking. There is kind of the closest thing to a default root account is there's the IBM user account, which is created when you first install ZOS, but you'll almost never find him activated. You use him to use that account to install the operating system, and then you revoke it, and it's almost always a dead account. So you can try it though, and it might have been sloppy. In RACF, you can assign surrogate profiles. So say an administrator doesn't want to be bothered by the regular users. to run it, because like maybe there's a job has to be run and it relies on stuff that the normies don't have permission to. So he just sets a surrogate profile. It says, okay, you can submit jobs as me, Bob, the admin. I have no idea how like this could be abused, right? You can just basically write a JCL job, say, oh, give me special permissions in RACF. So, that's another way to abuse it. And then also on a lower level, you have supervisor calls, and then you have APF authorized libraries. And what both of these do is they let you run code in what's called supervisor state, which in MVS, there's basically problem state, which is user mode, and then supervisor state is kernel mode. It's ring 0. So it's like you can access any protected region of memory. You can do anything. You'll see sometimes supervisor calls are system calls that are like user defined. You can write your own SVCs, and sometimes vendors write SVCs for their products to run on the mainframe. And if they're written really sloppily, they're sometimes referred to as magic SVCs, and they just let you run any code you want in supervisor state. So you can just go change memory directly and give yourself RACF special permissions or whatever you want to do, because it's just like a bit you flip in memory. APF authorized libraries, they're called libraries, but they're just those PDSs, partition data sets, like kind of like a folder. And the way they're marked is any member of that data set can run code in supervisor state. So if they screwed up and they gave normies write permissions to one of these APF authorized libraries, you could just write your own binary in like assembly language, add it to the PDS, and then run it, and then it'll go change memory for you. Another really good mainframe hacker out there is named Ayub El-Asal. He wrote a Privest script for this, which is great because you don't have to write your own assembly code. He just does it for you. All you have to do is run his rec script, tell it what library to do, and then it'll submit a job and then just like make you special, give you special permissions. Unix is a little bit different and it's a little more complicated. The usual tricks for getting root on Unix are all there. Like if they're using sudo, sudo's been ported. I don't know how many places use it though, because it's fairly recently been ported. But if they have bad sudo permissions, exploit it. If they have stuff with like set UID 0 on it and like you can do dumb shit with it, exploit that. But getting root does not mean getting root on the MVS side. You're just the king inside of Unix. It's very much like WSL. If you're root in WSL in Windows, like it doesn't mean you're the admin of the box. But there are some workarounds. I mean, RACF is still in control here. RACF controls all those permissions. But there are some workarounds because there are APF authorized binaries in Unix. And that's another path is like you can just write a custom C file, mark it APF authorized if you have the right, and then execute that and change memory and give yourself RACF system special permissions. Or my sole contribution to mainframe hacking so far is I found a way to get it is just by backdooring like the system programmer's freaking Unix account using SSH keys, which I'll show you a demo of that in a minute. So once you're on there, some lateral movement stuff, you can dump the RACF database and try to crack it, because if they're still using, even if they're using the newer stuff, it's just like anything. If you dump, like the shadow file in Unix, you can run a cracker against it. John and Hashcat both support cracking it. John has a tool to convert a RACF database into a John-friendly format called RACF to John. Actually, check for it first thing, because some places screw up and give users permission to copy the RACF database. You run rvary and it'll tell you the file locations. It'll usually be something like sys1.racfdes or something like that. It'll be different everywhere. And there'll be a backup one called whatever.backup. I usually just do the backup one to be safe. I'll copy that to FTP and exfil it. See if as a normal user if you're allowed to do that, because sometimes they've screwed up the permissions and you can just copy it off and take it on FTP and just go crack all the passwords on the system and just log in. But if it's a good environment, then they've marked it that only like system programmers can touch it. So once you've got those rights, exfil it and see if like other LPARs, if their user accounts are being shared across them. So then maybe you can just break into other LPARs without them to go through all those steps. And then also I mentioned NJE. Once you get on the system and you can get to everything, usually it's a data set called sys1.parmlib, and then it's a member called JES2parm. That stands for JES2 parameters. If you go in there, it'll have all the node names, and if they're using a static password to like authenticate to NJE, it'll just be there in clear text. So then you can just go and just like go to town all over the system. So now I'm going to do another video here, and I'll show you guys. Where's my mouse? Okay. Crap. Where am I? I'll show you my little attack path video using SSH. And apologies if this is kind of small. So here I'm going to show you I have a user named Eve. She's going to try and log into TSO. And she can't because she had TSO access, but it got revoked. So now her account number isn't valid anymore. So she's just going to disconnect. So she says, well, let's say it's a hacker. I'm a hacker. I stole Eve's password out of a config file somewhere. So I'm going to try and SSH as Eve. I try it. Okay, what's her password? Nope, doesn't work. Doesn't work. Doesn't work. Now don't worry, I haven't locked her out. She's actually just denied in SSH, the SSH config from logging into SSH. But she can log in with FTP. So I'm here as an FTP user. So I know I have permissions to that. So here I can see some files on there. And when you're an FTP, you start off on the MVS side, but you can do CD and then a Unix directory path, and you can move to that. Over here, I'm going to run the FTP JCL code execution Metasploit script. So all this is going to do is just run and give me a reverse shell on the mainframe in the Unix environment. So I've already preset the settings on all this, like the password and stuff. So your password was just her username. I told her you should have a crappy password. So I'm going to start that, and here it is. I've got a session on the mainframe in a reverse shell on Unix. So first thing I'm going to do is I'm going to start enumerating. And I'm going to do a find command to look for anything with set UID on it, and that belongs to user 0. There's no really a root user, but there's a UID 0, which usually has a name like start1 or start2 or something. And so there, the find binary. The find binary has set UID, probably because like the admin got tired of people, complaining about errors. So then I'm going to do the old, the old CTF trick. I'm going to do the exec flag and find and execute a shell. Now I'm UID. It's got some shit at the end, so I'm just going to do SU to throw all my UID to the front, and then run ID again. And there, I'm user 0, which in here they named it start2. They don't normally name it root. What I'm going to do is I'm going to generate an RSA key, and I'm going to skip forward because my emulator is really freaking slow, and it took like a good couple of minutes to generate that key. There we go. So I just saved this RSA key. Yeah, no passphrase or anything. I'm just going to generate it. So there it is. I'm going to set permissions on it so that I can copy it off of FTP. And then I'm going to echo the contents. Oh, here, I'm going to download it first. Yada, yada, yada. Come on. I'm going to speed this up a little bit because I'm running out of time. So basically what I did is I took that key and I copied it into Bob's .ssh folder and tagged it onto his authorized keys file. Yeah, sorry, I'm going low over time, but hey, I'm just keeping you all from eating, right? So that's no big deal. It'll be done very soon, hold on. Okay, so I carried that over. And then I'm just going to exit out of my interpreter session because now I've got Bob. So then I can go over here. I've got that key I copied over, and I've set the proper permissions or else SSH will yell at me. So I have that key that I put in Bob's SSH folder. And now I'm going to SSH using that as my identity file. Give it, no whammy, no whammy. And there I've got a shell. And I'm Bob now, and Bob is a sysprog. He's got all the rights. And now I can use the TSO command in Unix in order to run TSO stuff. So I can see here, I'm Bob, and Bob has special and operations, meaning he can change any RACF setting, and he can do anything to any data set on the mainframe. Eve doesn't have any of that, so sad. But I can change that. So now that I'm as Bob, and I didn't even have to know Bob's password, I can't go log into TSO because I have no idea what his password is on TSO, but I can get it to Unix. So I'm just going to run a shell script because, as I'm telling you here in my little comment on the shell, I'm too lazy to memorize all this shit. So what it's going to do is just going to run a bunch of RACF commands that are going to give Eve special and operations permissions and then allow her to log into TSO. So now I check Eve, and now she's got special and operations. If I was doing this in TSO, like say it was Eve and I ran an exploit to give myself special and operations, I would actually have to log out of TSO and log back in before it would take effect. But since I'm on Unix, I'm just going to, now I'm going to log in as Eve because I've gave myself TSO rights again. So here I am, I'm Eve. And I'm back in. So I can run ISPF, And see, this one's a little different. It's the commands down at the bottom. Like I told you, they customize a lot of stuff in mainframe land. And there I'm Eve, and I've got special operations, so I've owned the mainframe. Okay, so here, I'm almost done, I promise. Now y'all are getting hungry. So anyway, that's my favorite hacking video. I love that guy. I think it's from Mega64. So how can I start learning mainframing, or learning how to hack mainframes or use mainframes? Obviously, if your company's got one and will let you use it, go ahead. The other official way is IBM has an official emulator package. It gets rebranded every couple of years. It's currently called ZD&T, Z Development and Test Environment. And it's about $5,000-ish. Kind of depends on like the licensing and like how much CPUs you have, how many users, whatever. And it's like an official emulator that'll run on like x86. You can run it on a laptop, or you can run it in a cloud server like AWS or Azure. You can also sign up for the IBM Master of the Mainframe competition, which that's the first demos I showed you was on that box. It's their student outreach to try to like save the dying mainframer species. If you're a college student, you're actually eligible to compete and like win prizes, but if not, you can just go and you could go register for the learning system, and they'll give you a mainframe account. Cons are that sometimes it's not available. There'll be certain times of the year it'll be down for maintenance or because the competition ended. And also you can't hack on it. They highly discourage that. The other way is Hercules, which is an open source mainframe emulator. IBM hates them. Like I've heard IBM employees are verboten from like using it. It's maintained by Tron guy, Jay Maynard, who old internet heads may remember him from like early YouTube. He's like one of the maintainers of it. The legal way is you can find like public domain versions of MVS, like the old operating system, and you can like run those. And that's small and like lightweight enough. You can even run it like on a Raspberry Pi. But like things like RACF and stuff aren't public domain, so they had to take those out and put in like drop-in replacements for it. It'll get you familiar with it, but it's kind of funky. And it doesn't have Unix. It's missing some like newer features. The not so legal way is you just go find a bootlegged like dump of ZOS. Like some guy dumped like the ADCD, which was another one of their like emulator packages several years ago. Some guy like just burned his bridge with IBM and just dumped it all to the internet. So you can run that too, and that one you can hack it, and it's about 10 years out of date now, but like it's not too bad. It'll still, you'll be able to still do most of the things you can do in like modern up to date ZOS. Honorable mention to zos.efglobe.com, which is some weird Canadian company that just has a public mainframe, and you can go on their forum and ask for a user ID. I've never used it, but I know people who have, and yeah, it's an option. And then also you'll need a TN3270 emulator. You saw I used X3270. That package also comes with C3270, which will run inside like your terminal session instead of having to use X. It's available on Mac. You can run on Windows via like WSL. And there's Mochasoft has a couple commercial ones for like $30. You can get a free license for Vista TN3270 for Windows if you sign up for Master of the Mainframe. And then here's some links to different stuff. And also in this presentation, when I put it up online on my blog, I'll have a big reference section in the back that has links to all the tools, other people's talks on mainframes, blog articles, different stuff. Lastly, I want to say a big thanks to Phil Young, Chad Rickensrud, and Austin Robertson, who all helped me with this presentation and peer reviewed it for me and gave me good advice. Big thanks to L.U. Belisol and Dominic White, who've done a lot of great work on hacking kicks and privesking. CackalackyCon for not sticking me in the crappy morning slot. And thanks to all of you for attending. So otherwise, get the hell out of here and go eat lunch. If you want to talk to me about mainframe stuff, I'm available for questions. Just come hit me up. Thank you, everybody.